Introduction to Electrical Discharge Machining (EDM), a revolution in precision manufacturing, presented by NORAZMAN bin Abdurrahman from Group Number 1. Electrical discharge machining represents a transformative approach in precision manufacturing. Utilizing controlled electrical discharge, EDM enables the machining of material previously considered too hard or intricate for traditional methods. This non-contact process finds extensive application in critical industries such as aerospace, biomedical, and marine engineering, offering unmatched precision and flexibility in handling complex geometry. What is EDM? EDM stands for Electrical Discharge Machining. It's a non-traditional machining process that uses controlled electrical discharge to erode material from a workpiece submerged in dielectric fluid. It is especially useful for machining intricate shapes and materials that are challenging or impossible to machine using conventional methods. Why is EDM important? It is important because it's ideal for hard-to-machine material such as titanium alloy. It enables the creation of intricate geometries with exceptional precision. Widely used in aerospace, biomedical, and marine industries where traditional machining falls too short. Working principle of EDM. Working principle of EDM is divided by 5 main parts. The first one is setup. In the setup, the tool or electrode and workpiece must be electrical conductive and are submerged in dielectric fluid such as deionized water or hydrocarbon-based oil. A small, precisely controlled gap 10 to 100 micron called the spark gap separates the tools and workpiece, preventing premature discharge. Number 2, electrical discharge. A power supply delivers high-frequency electrical pulse to create spark between the electrode and the workpiece. This spark produces plasma channels where temperature range from 8,000 to 12,000 degrees Celsius, causing localized melting and vaporization of the material. Material removal. The molten and vaporized material is rapidly cooled and solidified into debris by dielectric fluid, which also flushes the debris away from the machining zone. This cyclic heating and cooling process removes material layer by layer with incredible precision. Dielectric fluid rolls act as an insulator to control spark generation, cool the machining zone, and flushes debris. The fluid also helps maintain stability by preventing secondary discharge. And the last part is cyclic nature. Thousands of electrical pulses occur every second, allowing precise material removal while maintaining the integrity of the workpiece. Over the time, the repeated sparks shape the material into the desired geometry. The conclusion for EDM introduction is EDM is transformative technology that allows precision machining of integrate a hard-to-machine material with exceptional accuracy. Its ability to create complex geometries and handle advanced material make it vital for industries like aerospace and biomedical engineering. The non-contact process reduces mechanical stress, ensuring better performance and efficiencies. Thank you for your attention.
Assalamualaikum. We'd like to continue on the next slide. So this one is for advanced EDM technologies. Welcome everyone. Today we'll explore the cutting edge advancement in electrical discharge machining or EDM technology that is revolutionizing precision machining across industry. For the high precision machining, EDM has achieved remarkable precision level with tolerance at as tight as ±1 micron. This make it is indispensable tools for industry like aerospace and medical, also automotive, where high accuracy is critical for safety and performance. Okay, for the next, integration of AI and automation. A major leap forward in EDM technologies is the integration of the artificial intelligence and automation. The system can now optimizing machining parameter in real time, increasing productivity by up to 30%. This reduces waste and enhance efficiency, giving manufacturers a significant edge. For the next part, for the additive EDM techniques. Okay, another groundbreaking innovation is the combination of EDM with additive manufacturing techniques. This hybrid approach allow for the creation of complex geometries that were once impossible to achieve, opening door to new possibilities in design and functionalities. Together, this advancement highlight EDM roles in shaping the future of precision manufacturing. Okay, we go to the next slide. Okay, this one for the emerging innovation in EDMs. Let's now shift focus to the latest emerging innovation that are redefining the EDM landscape. Green EDM technologies. Eco-friendly EDM systems are leading the charge towards sustainability. This machine drastically reduce the use of dielectric fluid and cut power consumption by up to 40%. This not only reduce cost but also minimize the environmental footprint of manufacturing. For the next item, for the now EDM development. So nano EDM techniques are another frontier, enabling the machining of components at a nanoscale. This capability is crucial for industry like semiconductors and MEMS, which demand unparalleled precision at microscopic levels. For the 3D to pass optimization, finally, advanced 3D to pass optimization software is transforming efficiency in EDM process. By reducing machining time by 35%, manufacturers can achieve greater cost effectiveness without compromising qualities. This innovation reflects how EDM continues to evolve, meeting the dual demand of technology's advancements and environmental responsibility. Okay, we hand over to next slide, presenter.
Okay, Assalamualaikum dan selamat sejahtera. Pak saya akan menerangkan berkaitan dengan industrial application of EDM advanced machining, iaitu apakah kegunaan electrical discharge machining dalam industri. Dia ada banyak dia punya applicationnya. Di antaranya ialah yang pertama tool and die making. Jadi EDM ni manufacturing dia untuk buat mold, die, tool komponen dan benda yang sangat kompleks lah. Dia punya shape yang kompleks dan detail dia boleh buat. EDM ni boleh buat lah dan terbaik lah. Kemudian dia juga digunakan dalam industri aerospace, untuk angkasa, untuk komponen-komponen seperti terbang blade tu, untuk disebabkan dia boleh buat surface finish yang paling cantik lah, surface finish kan, atau komponen yang buat daripada super alloy, dia dengan mudah dia boleh create lah. Okay, kemudian guna untuk industri otomotif, iaitu digunakan dalam manufacturing mold and die, kemudian design komponen-komponen untuk gear. Jadi dia boleh buat komponen menggunakan besi yang keras, di mana mesin-mesin lain susah nak buat, dan dia boleh buat lah shaft dan gear. Kemudian industri medical untuk industri perubatan. Dia boleh buat untuk menjadi mold kepada picagari contohnya. Kemudian implan, dia boleh buat implan untuk besi-besi yang dimasukkan pada kaki, tangan semua tu, untuk human body, material dia. EDM adalah pilihan yang paling sesuai lah. Dan dia juga kelebihan dia boleh buat yang berilmu industri micro machining, maknanya yang kecil, yang dia boleh part-part yang sangat kecil boleh dibuat dalam micro machining lah. EDM boleh create, dia boleh operate untuk lubang yang sangat kecil, shaft yang kecil, dan seterusnya. Dan yang keenam adalah industri electrical contact dan connector lah. Jadi dia sangat baik untuk produce barang-barang electrical connector lah, yang electrical resistant, kemudian dengan surface yang sangat cantik dan boleh apply untuk part-part yang halus lah. Kemudian part-part yang penting untuk high current load punya, jenis-jenis besi yang diperbuat daripada tembaga, dia paling cantik lah, dia boleh buat. Jadi secara keseluruhannya saya boleh simpulkan EDM ni dia merentasi semua industri lah, dia cross semua industri lah, dalam high quality components, daripada komponen biasa hinggalah kepada high quality komponen. Dia punya penghasilan sangat cantik lah, cantik. Itu saja penerangan daripada saya. Terima kasih.
Hey everyone, my name is ABDULLAH and I'm from Group 1. So today I would like to present about the challenge and limitation of EDM advanced machining. Okay, so for the challenge and limitation of EDM, the first is high initial investment cost. Advanced EDM machines are expensive to buy and set up because they have special part and complex control, and this makes EDM difficult for small business to afford them. Next is toolware. Electrode get used up during machining and needs to be replaced often. This increases cost and can lower machining efficiency and surface quality. Next is lower material removal rate. EDM is slower method. It removes small bit of material with electrical discharge, and it's taking more time, especially for the large or thick part. It makes it less fast for the big job. Next is skill requirement. Operating EDM machine needs special skill. Without trained worker, it's harder to use EDM well, which lower productivity and efficiency. This lack of skilled worker is challenge for companies trying to keep precision and productivity high. Next is surface finish and accuracy. The EDM process can leave a recast layer on the surface, which may affect the material properties. Achieving a high quality surface finish can precise dimension and can be challenging, especially for complex shape or tough material. Next is complex process parameter. EDM machining has many factors to adjust. Setting them right takes skill and time. Finding the right balance is important for the quality, but it makes the process more complex and slower. Next is material limitation. While EDM is effective for conductive material, it cannot be used for non-conductive material. Limiting its application is certain industries. Additionally, the process may not be suitable for all types of alloy or composite material. Next is environmental effect. The use of dielectric fluids in the EDM process raises an environmental concern regarding waste disposal and also potential hazard associated with the fluid management. Next is non-productive time. Non-productive time like tool change, unnecessary movement, and also adjustment for tool wear can lower the production efficiency. By organizing the operation and using fast automation algorithm, this downtime can be reduced, leading to fast cycle time and also the better overall efficiency. Next is thermal effect. The EDM process generates a lot of heat, which can cause the thermal damage like a recast layer or change to the material structure. This may weaken the material and cause crack, especially in the material with low thermal conductivity like the superalloy. So that's all for me for the challenge and limitation of EDM. Thank you so much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning. My name is Ahmad bin ZAKARIA. I will present about electric discharge machining in teacher's book. Okay. In the journal, I will present about teacher's book. I will give 5 opinion or perspective. First, sustainability and efficiency. Sustainability is a key focus. Feature EDM process aim to use less energy, reduce tool wear, and minimize waste. Advanced electric fluid and cooling system will support this goal. Similarly, new eco-friendly coating for EDM electrode will make manufacturing green. Number 2, handling advanced material. To meet industrial demand, micro EDM will involve to machine tough material like composite and ceramic. New electrode design and 3D printed custom tool will improve machining efficiency and surface quality. Number 3, smarter process. Technology like AI and machine learning will automate setting for better material removal rate and surface integrity. Real-time monitoring will ensure more reliability and efficiency machining. Number 4, hybrid system and stress management. Combined micro EDM with other process like 3D printing will enable hybrid system for producing complex parts. Improved model and simulation will help understand and manage residual stress more effectively. Number 5, energy and tool performance. Reducing energy waste during EDM operation will be priority. Long-term study and tool durability and costing will ensure better industry application. Last conclusion. Advance in EDM, metallization and stress modeling will make machining more efficiency, sustainable and suitable to modern challenge. Thank you for your attention. Assalamualaikum.